Welcome everyone to our star party. My name is Joelle Chili-Kale. I'm the development coordinator for the Long Point Basin Land Trust. We're really excited to have a lot of fun. I've already seen a really cool little preview of what we're gonna do tonight, so pretty excited for that. But before we do get started, just a few housekeeping items. As you're coming in, please make sure to keep your video off. We're going to turn off any videos that we see on. So just if you, just makes it a lot easier that way. Your microphone is muted. We keep it that way just to make everything nice and easy. So the best way to get in touch is to talk in the chat box. So you can see in here that there's that little chat button circle. That's if you are on a computer. If you're on mobile or an iPad, you're going to have to press the 3 dots. If you click those 3 dots, then you'll be able to see the chat and you can type in there. And so if you have any questions or comments or anything else going on while we're having this star party, that's exactly where you put them. I'm going to be hanging out in there during this, and so I'll be able to pop in and ask any questions. If you can't hear me talking right now, please make sure to press that join audio button. That's the easiest way to do that. And again, we're going to be recording the webinar. So if you have any connection issues, if you drop, I know lots of people are dealing with that right now. You'll be able to watch it later because we will upload it to our YouTube page and then we will send you an email, which is quite nice. And then the reason why we're all really here is because of the Long Point Basin Land Trust. So I work for them. We have lots of really incredible events going on, lots of other things. So make sure you sign up for our newsletter. You can check us out on our website, which is longpointlandtrust.ca. And then make sure to follow us on social media. So we're on Instagram, Facebook, and Twitter at LPBLT. Don't say that 5 times fast. You might get a little tongue-tied, but that's okay with that. And then where we're located. So I know from previous events that people tend to come from all over the place, which is really incredible, especially all over Ontario. Fantastic. But where the Long Point Basin is, we are part of Carolinian Canada. The Carolinian Zone is one of the most biodiverse regions in all of Canada, and the Long Point Basin is that little area there, and that's where we really work to protect our land. We have 10 nature reserves all across that Long Point Basin there. You can see them here. If you go to our website, longpointlandtrust.ca, that's where you can learn all about them. Some of them you can visit. They have trails, all of those types of things. This is exactly where to go to learn all about them. We've got different ponds, we've got different wetlands, all kinds of really fun and exciting things there. And of course, we'd be remiss if we did not thank our incredible sponsors. These wonderful sponsors are the reason why we are here tonight. So both with them, and then thanks again to people like you. So people like you are the ones who help to donate and make these types of events and education events possible too, which is really incredible. And we also wanted to plug our next event, which is a field sketching webinar, and that's with Megan Hebert. It's going to be really cool. I've already seen a little bit of a preview of it. It's going to be this really fun interactive thing. So you show up with a paper and a pencil, and she will take you through and show you how to do all this cool, fun art field sketching. I think it's going to be really, really fun. So be sure to stay tuned for that. You can sign up for that. The link for that is on our website, and it's going to be up on social media very, very soon as well, which is really exciting for that. Yeah, and so then without further ado, I am going to introduce Bernd Mueller here. He's worked most of his life in the printing trade. He's now retired, and though he doesn't have any formal education in astronomy, I can definitely vouch for the fact that he is incredibly passionate about all of this. And he's been looking up in that sky for over 50 years, which is really, really incredible. He's been president of the Kitchener-Waterloo Center of the Royal Astronomical Society of Canada. He's held a whole bunch of other different positions in that over the years. He's currently a member of the Hamilton RASC Center and is a past vice president of the North Shore Erie Amateur Astronomers and is a current treasurer of the club as well. So thank you so much for being with us. And I'm gonna turn it over to you and turn off my screen. Be sure to, everyone, make sure you hang out in those comments and let us know if you have any questions. Okay, all right, over to you.
Well, hello, everybody. So tonight we're going to be looking at the Moon, Jupiter, and Saturn are going to be our three targets. So right now we have the Moon. So let me see about. To go over here. And something's happened to the Moon.
So while we're waiting for the Moon to turn back up, maybe you could explain what it is this program is and where this view is coming from.
Just 1 second. Okay. So this is my. Well, that's a view of the Moon right now. So it's a live shot, just looking out into the sky. So I'm going to just stop for a second, and I'm going to show you what I'm working with here. So I'll just pick up my computer here. So I'm out in the field here. So there's my telescope. And we're pointing up at the sky. Now I'll point it in that direction. I'm behind the computer, so I don't know what you're going to see, but there's the sky, and somewhere in there, there's the Moon. And the telescope that you see is it's an equatorial mount. That means it has a motor on it that drives it. And it has to be very precisely lined up to keep the Moon in constant frame all the time. And what some people don't even realize is that when I set up my telescope for the Moon, I actually have to change the speed because the Moon is actually moving through the sky at a slightly slower rate than everybody, or faster rate, I don't remember, but you have to change it to a lunar rate. And the optics on this is what's called what people think of as a traditional telescope. It's what's known as a refractor, where you have the lens at the front. In this case, you have the camera on the back end. You would, or if I was looking at the Moon with an eyepiece, which is what we intended to do tonight, or I would actually intended to do it Saturday night, but unfortunately, getting together physically just wasn't the best idea. So what this telescope is about, it's 130 millimeters diameter, and it's a 1 meter focal length. And the setup right now that I have doubles that focal length, so it's basically 2 meters focal length equivalent. Now the rational thinking, a lot of people buy telescopes and they want lots and lots of power. What I tell people is that you can determine how much power you should, at least with an eyepiece, you can determine how much power you should put on the telescope by looking at the size of the objective. So if you have like this is 130 millimeters diameter, so you should have 130 powers. So every millimeter diameter, you should have one power. You go beyond that, you have to have really good optics and a really good sky and really good eyepieces. And everything has to work just right. Otherwise, your view just doesn't get that good. Now, you see a little jiggling. Right now, I'm touching the hand pad. to get ready to do a little virtual tour of the moon here. Now the moon is, I'm most of the time I look at and photograph deep sky objects, which means very, very faint objects. So the craters are something that I'm totally fascinated by, but I haven't studied them very much. Now, I do know one area. I think I'm swinging into it now. Oops, the buttons don't correspond. If I'm not mistaken, that area is known as Mare Tranquility. It's the Mare of Tranquility. That's where the Apollo 11, the first spacecraft, man first landed on the moon. A lot of people ask me, well, can you see them? Can you see where they landed? The answer is definitely not. Even the Hubble Space Telescope, with all the power that they have, can't see it. In fact, it was only 10, 15 years ago that a low orbit satellite going around the moon was actually able to take pictures of the stuff that they left behind. So I'm going to do a little more touring right now. Now it gets very bright on that side, so I'm going to cut the exposure a little bit here.
Diane wants to know, where's the flag? Can you see that? Was that where you were pointing at back there on the moon?
Well, that's the general area, but like I said, it took a low orbit satellite to even see any trace of it. It just gives you the sense of the enormous distance and enormous size of the moon, even though the moon is only a quarter of the diameter of the Earth. So we'll never be able to see any artifacts left by man on the moon, except for, I should clarify, there are a couple of artifacts that were deliberately left. They're called reflectors. And what scientists, NASA, whoever, they shoot a laser beam at the moon, and these laser beams, they target the reflectors, and the reflectors they can just make out the blip of light. The reason they did this is so they can accurately measure the distance to the moon at any time. But it's a very, very specific kind of thing. So I'll do a little more tour here. And looking at this with an eyepiece would absolutely totally blow you away. Like, this is not bad. This is I put a new camera on I just recently purchased, which I actually use in my deep sky photography to guide the telescope. A telescope is never 100% perfect, so you need a second camera to actually look at the star field every second and make a tiny little correction. And fortunately, it also does this wonderfully. It is a monochrome camera, so it's hard to tell because the moon is pretty much gray. But when I show you Jupiter and Saturn, it'll still be gray, black and white. Now I can't zoom anymore with the telescope, but I can zoom digitally. What you're seeing there, it's all atmospheric distortion. It's kind of like you're looking through underwater. But what astrophotographers are doing these days too, I haven't done any of this myself, but with this program and a couple other programs, I may start doing it. So you can take a video like this, and then you throw it into another program, and it'll throw out 80 or 90% of all the worst ones, keep just the really good ones, then combine them, and you can get some incredibly high resolution photographs taken from Earth. So I hope we can set this up again next year so that we can actually do this in person.
So Tom has the question of what are those brighter white areas that we're seeing there on the screen? Not quite there. I think there were some of them that were back a little bit further.
Yes, we were just back a bit. Yeah, those are part of what's called the ejecta, when all the craters on the moon that you see are I would say probably 99% of the craters that you see are all from asteroid impact. And then it throws out, I'll use my cursor here to show you. When it hits in here, then it throws out material, and it tends to be a little bit lighter in color. And that is just because it's overexposed, the edge is just showing a little bit. So if I go underexposed here a little bit, you see how it's just the edge catching the sun. What people don't realize is that the moon is actually very, very dark. It only reflects 11% of the light that hits it. Some people say, well, what's 11%? Well, 11% would be the equivalent of freshly paved pavement. So it's almost black. If you look at some of the other moons in our solar system, like on Jupiter, Callisto is an ice moon, it reflects about 90%. So you can imagine if the moon was 10 times as bright, reflecting 10 times as much light, how late the night would be with the moon shining.
So Diane says that means it must be very, very cold. Is that true?
Yes, it's very, very cold in the shadow areas and very, very hot if you're in the glare of the sun. Because there is no atmosphere, well, technically there is an atmosphere on the moon, but it's extremely tenuous. So if you're standing on it, the side that's facing the sun would be extremely warm, and the side that's not in the shadow would be extremely cold. So they had obviously very, very well insulated and heated spacesuits when they were walking on the moon. Now I'm going to quickly go away for a second and go to another program here. So go full screen on this one. Now, this is a program called Stellarium. It's completely free. It's a totally free program that you can download. And it's kind of like a planetarium. They call it a planetarium or like a star program. And you can see, I can zoom in on the moon just like what we were just watching. It's a simulation, of course, but there's something neat I want to show everybody tonight. It also has a time function. So you can go backwards and forwards. Not sure how far they go back and forwards, but certainly with anybody's lifetime, you can go backwards. Now I want to go forwards 4 years. You might say, what's happening in 4 years? So I'm looking for the sun. So if I go back a couple of minutes, this is what we're going to be seeing right from here in the Norfolk area. It's going to be a total eclipse of the sun. So I can simulate this. I'm just going to let it run. And this is just about there. And Sandy and I recently, well, 3 years ago, we went to the big eclipse, what they call the Great American Eclipse. It went across America. We went to Missouri, just an hour west of St. Louis. Unfortunately, we got clouded out. But still, we were sitting in a field. The morning, we saw the partial phase. And then we were sitting in the field. And as it got dark, and as you can see on the screen here, it's getting dark. As it got dark, you could hear all the life around you, like the insects were coming out, the nighttime insects, and there was chickens nearby, and they started squawking, and birds went quiet, and the whole atmosphere just changed, even though it was socked in. And that's what it looked like, and we're hoping we'll have a clear sky here. So I've already got friends who booked a room in our house here because the center line of the eclipse is going to be right over Long Point. So just being a little bit off Long Point here, we're right on the lake in Fish's Glen here. We're going to get a prime view of it. Unfortunate thing is, historically, this is April 8th, by the way. Historically, April is pretty cloudy, but I know there's people who are already planning on, comes up from Texas, who are planning on going to Texas. There's people who do eclipse chasing. They spend their entire life savings, or planning at any rate, to go chasing eclipse all around the world. So we'll just advance this a little bit. And you can see that, and it's really true, that less than 1% of the sunlight coming around the edge of the sun. It's bright enough that sometimes you wouldn't even notice, you just think it was a little bit dim out. So people weren't aware of it, that there was totality. In fact, in the St. Louis area, there was road signs warning motorists of a hazard about the eclipse coming, that it would be dark in the middle of the day. It's so quite staggering. So this is, like I say, a really neat program to do that kind of thing. And Saturn, Mars, Venus, and Jupiter will be visible in the sky. Of course, nobody will be looking at those because everybody will want to see the totally eclipsed sun. Okay, well, I'm gonna just head out on this one. Okay, I gotta go back to that one. So now we're still looking at the moon here. Just see how much time I have on the moon. Okay, just tripped over the telescope. I'm okay. Yeah, the moon is about, we've got maybe another half hour, an hour maybe, and then it's gonna go behind some trees. But right now I think I'm gonna move over to Jupiter, so. I'm gonna increase my brightness level. So there's Jupiter now. I'd say it's not impressive. Fortunately, the atmosphere tonight is not the best, so it's not as sharp as it could be. I'll try to adjust the exposure. I'll zoom in a little bit. Now, if you watch carefully, you can see right now, you can see the bands of Jupiter running straight across like that. And every now and then, as you're watching, you'll see that it gets really, really sharp. And that's kind of the atmospheric distortion that's getting there. And that's what guys do with these videos. They just snap those few frames that are really good. So I'm going to go back again. I'm going to show you the moons of Jupiter here. Going a little more exposure. Please bear with me a second here. I had to take it out of the moon rate that I was telling you about earlier. And there are the moons of Jupiter.
So how many moons does Jupiter have? And do you
I
know
was
which ones are visible here?
Yeah, I was going to look up that fact and I forgot. So at well over 80, maybe 90 moons now. Now, a lot of them are very, very small. So you have Io, Callisto, Ganymede, and I'm missing one. But these four moons are what's known as the Galilean moons. And the reason they're known as the Galilean moons is because they're the moons that Galileo saw when he first pointed the telescope at Jupiter.
Very cool. Romeo wants to know, why does it look like the moons are spinning at a fast rate?
That's probably the atmospheric distortion I was telling you about. We had a massive storm here. If anybody's not from this area, just an incredible storm came through this afternoon. And I had no hope of doing a live presentation tonight. And then after 6 o'clock, there's a few rays of sun, and I said, oh, this might work. And I had the telescope all set up. I had a tarp over the whole thing. So once it got somewhat drier, I was saying, let's go and set this up. But unfortunately, all that rain has got an incredible humidity, and the moon and Jupiter are very, very dim compared to what they were a couple of nights ago. So, and when that happens too, you also got a lot of what's kind of a, not quite a twinkling, but a swimming effect. I guess if on stars, it would be a twinkling effect. If you ever see a night where the stars are twinkling and you see a star that's not twinkling and the others are twinkling, well, the other one would have to be a planet, because planets, when you're looking at it just with the eye, really don't twinkle. It's because there's actual size there. Stars are so faint that they're infinitely small as far as we can see them.
So Tom wants to know if that atmosphere change, does that make the cold air in the winter better for observation?
If it's stable, yes. Sometimes it's not stable, but yeah, quite often the winter night sky nights are the best. Not the best for the astronomers, but they are best for viewing. So. In fact, I'll do a little, got a little PowerPoint presentation for you. And got a couple of pictures I took of a lunar eclipse in January of 2019. And I think it was the absolutely coldest night of the year. it froze my digital thermometer, and it got stuck at about -26, so it was somewhere below that. So if there's objects that I like photographing in the wintertime, I try to do it in the fall, because in the fall at 3 in the morning, you see all the stuff that's up in the sky in the wintertime. And the wintertime, there's lots of cables and stuff on the telescope. They tend to get stiff and frozen, and there's more things to go wrong. It's quite incredible how much stuff can go wrong. It's on a good night, it's bad enough, but in the wintertime when everything is frozen and you can even you have to take your gloves off to touch a telescope, and it's very, very, very cold. I definitely try not to lick the telescope. So. Okay, well, we got that. So I'm gonna maybe, well, we're at 75%, I'll leave that. I might move it over to Saturn for a bit. How's that? I'll try not to trip on the telescope this time. It just did it again. Fortunately, I have to set the telescope up very high because my house might have gotten in the way, so which means I have to get up on a step to go to the finder scope. This is a go-to telescope, so it means that it's directed, but because I set it up in the daytime, I didn't do the alignment for it. So.
Romeo says, my daughter would like to know how many light years would it take Buzz to get to Jupiter? I'm assuming he's talking about Buzz Lightyear?
Yeah, Jupiter is only a few hours away.
Yes, he is talking about Buzz Lightyear from Toy Story. So Jupiter is only a few light years away?
A few light hours.
Oh, light hours, okay.
Yeah, I'm not sure, maybe 10 hours or 12 hours, somewhere in there.
Oh, so wow, that's a lot closer than I was thinking.
Yeah, it's quite close. So it's all within the solar system. Nothing is very far away, relatively speaking.
Sure.
Now this is probably I'd have to say one of my absolutely most favorite objects in the entire sky. I'm not very good at photographing it. Planetary photography is very difficult, but putting an eyepiece to this is absolutely amazing. People don't believe me when I tell them when they're at the eyepiece, when we have a physical star party, that you're actually looking at a planet. What you would see on a night like tonight, well, maybe tonight isn't the absolutely best night, but on a really a little drier night, this would still be a really fantastic sight. So you can see the rings around here. You can see the division in there. Like when Galileo first saw this, he was totally blown away, and all he could really make out was his optics were that so poor, but it was still absolutely magical to see this. I never get tired of sitting at an eyepiece and watching this. So I've blown it up a bit. Like I said, the atmosphere is playing with me tonight, so we can't quite get it all. But and again, you can also I'll go back. So like I did with Jupiter, you can also see the moons of Saturn. Takes a lot of exposure though.
So Tom would like to know, what colors would the planet be if this wasn't in monochrome?
Oh, there you go. You can see some moons. Saturn is kind of a yellowish, orangish colors. Jupiter is whitish, and well, kind of whitish with red and yellow markings, and same with Jupiter. So on Jupiter, you definitely see the bands going across it, and some are red, some are gray, and sometimes you'll even see a shadow going across from one of the moons. So you definitely can see the colors of it. So this is taking a very long exposure, so you can see I'm seeing 1, 2, 3, maybe one there, 4 moons. And it's kind of one of the tricky dilemmas of planetary work too, is focusing your telescope when you got a camera on like this. And sometimes that's easier done by doing it on a moon than it is by.
So how many moons does Saturn have?
It's also way up there. I think it's over 70 moons. And we can see probably half a dozen of them, maybe even more. They tend to be a little bit more evenly brightness, but they're relatively faint though. So, but we can't see them. Problem with Jupiter, I've never seen more than the 4 Galilean moons. I've never made a big effort to try to see more. But Jupiter is so bright that when you're looking at it with a telescope, because all the light from the telescope is going through the eyepiece, it almost blinds you to the faint objects. So you almost have to put Jupiter outside of the field and then try to look for the moons. So, maybe that should be a project of mine. So
that would be a fun project. So Jean wants to know, are the rings composed of gases? What makes the planets different colors?
Yeah, the outer planets beyond Mars are what are known as the gas planets. But the rings of Saturn are actually broken up moons. Jupiter also has a ring, but it's a very narrow ring, and Uranus and Neptune also have very skinny little rings. So Saturn is the only one with big rings like that, and it's rocks and icy particles. The problem when a moon gets too close, the gravitational forces on it totally break up the moons.
So where do the moons come from then? Are they broken off from other planets? Do they get new moons all the time?
Some moons are created when the solar system was formed, so there was rocky bodies and planet forms, and then there was other debris, and some are captured asteroids. Our moon, the leading theory right now for our moon is that actually a Mars-sized object hit the Earth in the very early days and threw off enough material that kind of was floating around like a ring, and then gravitationally bound it and made it into a planet, into a moon that goes around us. One other thing, if you don't watch the moon a lot, especially through a pair of binoculars or a telescope, you always see the same side of the moon. The moon is what's called tidally locked to the Earth. So over the billions of years that it's been going around us, the one side is heavier than the other side. So that gravitationally process has put the orbit into a locked orbit so that it's always facing us. Now, it's not always facing us 100%. So we can actually see sometimes it goes a little bit east, sometimes a little west, sometimes a little north, sometimes a little south. So from Earth, we can actually see about 58% of the moon. And that's another thing. I know a few people in the Kitchener-Waterloo Club who are absolute moon fanatics. They can name practically every crater, and they plan their sessions and their time for looking at the moon when the one side goes into favor or the other side goes into favor. So there's a lot of different things you can do in astronomy. So maybe we're getting a little tired of Saturn. Why don't we do, I'm just kind of looking up at the moon, and if anybody is stepping outside, there's a haze over the moon right now. So we might end up with a hazy situation. Oh, okay, there we go.
So most of the planets then, or most of the moons for the other planets, all came from when the solar system was created, or do they come from, or is it a bit of a mix?
The majority of the planets, or the moons I should say, or the bigger ones at least, are probably when the planet formed. And the smaller ones may have maybe like captured rocks, asteroids or comets and things like that. Like our moon is one of the biggest ones in the system. I think Titan might be bigger, or one of the Jupiter ones might be bigger, but it certainly is one of the biggest ones. Mars has two little rocks, and they're more than likely just captured asteroids.
So Lisa wants to know, have you ever seen a UFO or anything in the sky that you weren't sure what it was?
Yes, this is a question that comes up quite often. And what I tell people is I've spent many nights, the entire night, outside with my telescope. And I go to star parties where we spend whole weekends, 3 or 4 nights in a row outside with a telescope with 1,000 people looking up. And I've yet to talk to any astronomer who will admit that they've seen a UFO. So like typically we can explain what they are. Because a lot of times Venus rising or setting, rising in the east and setting in the west, can be extremely bright. And there's a little phenomenon called, I'm not sure what it's called, but it's kind of a fixation. If you fixate on watching a point in the sky, your mind will start to move it. Even though the object isn't moving, you actually think it's moving. And then there's lots of other things like satellites in the sky, bright stars, all kinds of things that can be attributed to being a UFO. But like I said, it's for as much time as amateur astronomers spend looking up, nobody's ever reported a UFO. So I guess that, in a way, that makes me a non-believer. So yeah, I'm gonna just show you a I'm just going to go down and show you a few pictures here. We went too far. Now, most of these I took, but I'll tell you if I didn't. So this is a picture of the Milky Way. Just happened to, the camera was tilted to capture that, so the foreground isn't level. And this is probably just 30 seconds with a DSLR type camera. And that's a Milky Way with a satellite, or a, more than likely a meteor going through it in the top. Now, this is not one of mine. I've seen over the years absolutely fantastic displays. Never really gotten fantastic pictures of it. You have to have the right equipment at the right time. I never seem to be able to get those two together. But if you ever seen a Northern Light display and it shines up, I mean, I've seen ones bright enough you could pick up a book and read by the light of them. And I've seen ones, if you look at the First Nations people have a lot of interesting paintings and things. And been up on Lake Superior and you look straight up and there's a Northern Light display. And exactly what the First Nations people have been painting all these years is exactly what you see looking straight at the zenith. This I would like to say I took, but I didn't. This is a meteor shower. And what this person did is took a meteor shower, or took lots of shorter exposures, and then put all the ones with meteors and stitched them all together into one picture. This would absolutely be amazing to see. Like, well, I've seen some meteor showers like this, but to see this many coming at the same time.
Romeo would like to know, can you share any info you may know about the possible meteor we are supposed to expect in November?
Or the meteor shower, the Leonids. Yes, there's a Leonid meteor shower happening in November. And that's typically, that's a good one. I don't remember what the moon is. The moon is bright, then it makes it harder to see the faint ones. But it's typically a very good one, except it does get cold out, so you're not as likely to go lying in your field. And the interesting thing about the Leonids is that every 33 years, the Leonids flare up. They go through, I guess, a dense patch of clouds, like dust clouds in space. And the last one was in 1999. And I was down here that weekend, and got fog from one end of the lake to the other. And people were up in the Tobermory area, and they said they were totally blown away. Like, when you think of a typical meteor shower that we would see here, you would see maybe a dozen, 20, 30, 40 meteors in an hour. This, you were seeing 20, 30 meteors a minute. Like, it's literally a shower. It's just raining stars on you. So the next one then is coming up. Well, we've got another 13 years to go. So I know 12 years to go. So this is not one of my pictures, but I've seen these, again, not photographed them. They're much easier to see from northern latitudes. These are called Noctilucent Clouds. There is water vapor that's been excited or altered by tiny meteors hitting the earth, and they burn up, but they leave this water vapor dust behind. And then late after sunset, you can see it's kind of red on the bottom, but the sun is still shining way up high in the sky, and you'll see these bluish trails of clouds. And then after a while, they go away. Now, if you're looking at the sun, you always have to have the right equipment, so you have to have a proper filter to put on your telescope. And that's what you can see. You can see sunspot. Right now, we're in a sunspot minimum. The last 2 or 3 years, we have had, I think, 80% of the days, there has been no sunspots at all. We've hardly had any big ones at all. But we're supposed to be moving out of that, so. Well, this is just a quick slide to show you how small we are. You can just take that in when you compare the sun and each picture you go down and how much bigger the stars are, the big stars are. You may have remembered back in the winter in January, February, the one Betelgeuse there. which is in the constellation Orion, was fading, and they weren't sure what was going on because it shouldn't have stayed faded so long. And they were thinking it was fading because it was kind of imploding and then it was going to explode. But it didn't do that. It started breaking again.
So in regards to those meteor showers again,
okay.
They say they hear one is expected to hit the Earth big enough that we need to be worried about it. Have you heard of that one?
Well, that would be like an asteroid type of a hit. That's a little more serious than a meteor shower, but yes, there is ones, and I think our next really concern that we have will be in about 2036. And that one is just going to be close to us. And then, then we don't know what our gravity will do to it the next time it comes around. And when I've talked like this one, I think when they say it's going to be close, it's going to be like 20,000 miles away, which is extremely close. And unless Bruce Willis is around to rescue us, we're kind of out of luck if something is heading toward our way. So now here's some eclipse pictures. These are I took from this area. It was a partial eclipse, just at sunset, as you can see. And really fascinating to see. Like even the partial phases are really neat to see. And there's the path of the eclipse. So it's going right straight over Lake Erie. Like couldn't have placed it better. So I think Hamilton will see totality. Kitchener-Waterloo won't, but we'll get about 4 minutes, if not a little bit more here, which is a pretty long eclipse. I think the longest you can get is about 7 to 9 minutes. This is, you can get on this National Solar Observatory. It's called GONG, actually, is what, if you look it up. It has what's called hydrogen alpha. It's a very specific wavelength of light. I take pictures and you can see them. And this one was taken back in February. And it was, use my cursor here. There's a big one there that day, and there's a big one there, a big one there, and big one there. Pay attention to that one, because that was that one taken a couple of days later, or the same day, but with a close-up. And somebody did a nice job of this, and they put the Earth into scale. So that's how big that is. And we just saw the moon. Now this is a neat effect. You can see this without a telescope, or with a telescope, but without a camera. But even though there's the dark side of the moon, as everybody knows, somebody cued the music here, that you can photograph the dark side, and it's the dark side, there's no sunlight hitting it, but it gets lit up by the clouds, or the sunlit side of the Earth. So it throws a light right back at it. And this is Jupiter and Venus here, and then a few other stars in the background. Now, people say, well, what's the best way to take a picture of the moon? I says, well, you got to get up close. And they say, well, how close were you when you took this one? And I told them I was about 10 feet away. I'm not an astronaut, but that's how close I was. They brought the moon to Stratford. This was a globe constructed with high resolution photographs taken from a lunar orbiter. And they made this, I think it's about a 20 or 30 foot diameter moon. And they hung it suspended, and there was lights inside it, so once it got dark, it lit up. And they had it sitting on one of the Patterson Island, I think, in Stratford. And they had it there for a week, and every night there was some different types of music and an old little festival going on. It was actually quite a neat little show. But that's how you get closer pictures of the moon. Now, people say, well, can I take it with just my regular little camera? And I said, yes. This is just taken with my point and shoot camera at maximum zoom. It goes about 80 times. And just handheld. If I put it on a tripod, it probably would have been better. But still pretty good for just a handheld picture. And these next couple of pictures I didn't take. These are people who've done some really nice job on high resolution pictures of the moon. Now, if you pay attention, you can actually see some really neat artifacts. I think a couple of days ago, later in the night, I was out, and Joelle and Kristen were watching online when I was here. I could actually see this little part, the one part of this, not that part. What this is called, it's called the X on the moon. It's some ridges on the moon that when the light strikes it just at the right time, you can see that X for about 2 or 3 hours. And then the moon turns and it goes away. And this is not a satellite picture. This is an amateur took this picture. And again, they do it by the stacking method, and picking the best ones. So I might just try that with this new camera I got. So this is the lunar eclipse I was telling you about from 2019, where it was just absolutely incredibly cold. I set the telescope up, got it tracking, put the camera on it, put the timer on it, ran inside, let it go for a few minutes, go back out, check it, take some more pictures. You have to be dedicated or crazy to sometimes do this hobby. So now look at some of the planets. Mercury. This is an Earth-based shot somebody did. This is a planet I've only ever probably seen maybe 6 times. It's always very small and it's very low to the horizon and very difficult to find, even though it's relatively bright, but it's so low to the horizon. You have to be almost sitting on top of a mountain or something to see it. But amazing somebody got some detail on it. Now, Venus is easy to see. It's also somewhat low to the horizon, but it's so bright. When you get it close to the sun, when you see it just after sunset, you'll see that the spikes, because of the atmosphere, it's putting the light, bending the light all the way around the planet. So you see that crescent is more than 50%, like more than 180 degrees. This is your more typical view. When I put this in the telescope, people often say, well, why are you showing me the moon? No, I'm not showing you the moon, I'm showing you Venus. Okay, this is pretty exciting. This is Mars, a good picture of Mars that I took. Now, a friend of mine lives in Baden, but he's one of the top planetary photographers in Canada. And this is what he did. So he goes out, he has a 14-inch telescope. It's about 4 meters long, probably puts a doubler on it, so it's like 8 meters, like it's optical focal length. It's not physically 4 meters long. Puts a doubler on it, makes it twice that long. Then I talked to him once and he says, yeah, he has an observatory where it's all set up. He says, sets his alarm clock for 3 in the morning or whenever it's best. Goes out, swing over, get the camera on, do a sequence, go to bed, and then the next day process them. But pretty spectacular nonetheless. I mean, there's people in the States and in Europe, Southern Europe and that, and Africa and whatnot, who get better pictures because the atmosphere is better, because the planet, everything in the southern sky goes higher in the sky and becomes clearer. So this is what we saw earlier, similar Jupiter shot. That was mine. This is my friend Daryl's Jupiter shot. I'm not sure if there's spots on it. And there's something called, I think that might be just coming into view here. There's something called the Great Red Spot of Jupiter. So with a good telescope, by the way, somebody was asking about colors. this is about what you would see on a good clear night. And there's what's called a great red spot, which is a storm on Jupiter that's been going on since, well, since Galileo first observed it. So it's been going for over 400 years. And this is a really good shot of Saturn. Now, I'll show you some comet shots here. All these comet shots are mine. So this is Comet Lovejoy a few years ago.
So before you get into comets, just a couple questions about some of those planets there. I know we talked a little bit on about flags on the moon not being visible earlier, but do you know offhand what countries' flags were left on the moon? I know they're not quite visible from Earth, but are there any flags that were left on there?
The only flags were the Americans. There are some robotics. There are some unmanned spacecraft that may have flags on their spacecraft, but they didn't actually plant a flag. The Russians have landed a spacecraft with a little rover. Chinese landed one last year. I think it's actually still operational. But as far as an actual flag goes, the only ones you'll find on the moon is United States of America.
And why does Mars appear red in the summer? Jean wants to know.
Well, it's known as the red planet. I think it has a lot of oxide in its dirt. So it's kind of like what we'd call rust, basically, kind of like PEI. So there is water, but there's no real, like it's all ice. So there's polar caps, which are, could be wrong. I think it's mostly dry ice, so it's carbon dioxide. So you can see, now you do need good power, but you can see the polar caps, and you can see the features on Mars. And you couldn't, like modern telescopes, what amateurs have these days, absolutely amazing. Because when you think about even like 100 years ago, astronomers had the quality of the optics were nowhere near what we can get now. They really worked hard to see a little bit that they could, but we can see all that now. But it's basically because the soil and the rocks and everything on Mars are red, so the sunlight shining on them just reflects back red light. Now, you might have seen this recently. This is Comet Neowise. That was just in the sky back in July. So I went out. First, I think this was taken in early morning, about 4 a.m., just before sunrise. And then it kind of moved in the sky to be in the evening. So this, I think, was taken in the evening. It was fairly a little bit low on the horizon, so I was kind of looking north, and the lights of Simcoe were kind of lighting up the sky. It's kind of a wider shot of that. And what you're seeing at the top, that streak, is actually the International Space Station coming through my picture. So. And this is a comet called Pan-STARRS. There was a couple of them. I forget which one this was now. And this shows a classic two-tail. If you go back to the other one, you look real closely. Where's my cursor? You can see a second tail going up here. You might not see it in my pictures that well. Yeah, you can see it better here. You see this guy here. And there's something called an ion tail and a dust tail. The dust tail is when the comet travels through space, it leaves behind dust. But the ion tail is the material that gets blown off because it's ice and things like that. That's what it's made of. And it blows the solar rays blow it away. So the ion tail, sometimes it can be in front of the comet rather than away from the comet. And here it goes like on 90 degrees opposite directions, so it really showed it up nicely. Now, sometimes comets aren't that spectacular. This is a picture of a comet. You might ask, where is it? There it is, that little greenish blob. It's Comet Jack, just a little guy. And this is called Comet Pan-STARRS. And this is Comet, that was the first picture I took of that. And then a month or so later, it was in the morning sky next to the Andromeda Galaxy. And also, so you see the big Andromeda Galaxy here. And this streak of light happens to be Meteor that I happen to catch in the picture. So kind of got three unique objects in one photograph. And the reason it's so bright up in the corner is because it was close to a full moon night, so the moon was shining in the sky. Trying to ruin the whole thing, but I managed to get around it. So now people ask me, well, I tell them I'm an astronomer, and they say, oh, you look at stars. Stars are actually very boring. They're like, if you look at any one star, there's really nothing to look at. It's just a point of light. It's when you get star clusters, like open clusters and globular clusters, that's when they become interesting. This is the double cluster in Perseus, a couple of globular clusters. And that green thing actually happens to be a comet. Now, if anybody has a Subaru, they'll know what this is. This is the asterism known as the Pleiades, or M45, where we have a naming system for all the objects in the sky. M is one of the shortest lists, but it's one of the first lists ever done. But if you take the same object and you expose it for longer, you'll see that there's all kinds of gas clouds around it. You can almost never see this unless you have a really big telescope. And this is M4, so it's another one of the M objects, the globular cluster in Scorpius. And if you look to the bottom left, you'll see another smaller cluster. So you see clusters within clusters. I think this is M92 in Hercules. This is M13 in Hercules. This one I haven't seen. This is, if I'm not mistaken, these two pictures are taken with about the same telescope, similar telescope, I should say. This is called Omega Centauri in the southern sky. This is just, if you put a telescope to this, it's just supposed to blow you away. So sometimes, and you can see this going down to like about Texas or so, somewhere in there. It'll be low in the sky, but you can see it. It's actually theoretically possible to see it from Norfolk. It comes up about 1 degree above the horizon, but usually that's cloudy. So then we've got nebulas, which is one of the things I really like photographing. That's the Great Nebula in Orion, M42, easily visible with the telescope, just fantastic. No matter what size telescope you look at this with, you'll see the wings in here. You see this here, you see a little cluster of stars, and you see wings out here. You won't see not all of this, and you won't see color. One thing people are very disappointed on when you're looking at nebulas through a telescope, you never see color. Because your eye, they're too faint, and your eye isn't sensitive in color when it gets really faint. Now, unless you have a really big telescope. I know somebody looked through an 8-meter telescope and he said he saw color for the first time, but it's not often you get that kind of opportunity. This is a little crescent nebula, this somewhat visible in a big telescope. This is the Horsehead. Love photographing this. It's in the constellation Orion. I've never seen it. Again, I need a telescope of at least 2 feet, maybe 3 feet would be better. And absolutely a fantastic sky. So it's a very faint object, but it's really neat to photograph. This is a nebula called the Helix Nebula. It's somewhat in the southern sky. Like you can see it from here. It was taken from here, but this is M27, it's called, the Dumbbell Nebula. beautiful in a telescope. You get a chance to look at it. If you anything probably 4 inches and up would be a fantastic sight. This is the Ring Nebula. It's probably one of the easiest objects, called M57 is its designation. Fairly small, but fairly bright. So when you see it in the scope at low power, you see almost like it's a big star, and then you crank up the power and you see the ring. And in this picture, you can see there's a star right in the middle. It's a little challenging to see that with a telescope, but if you get a good night and a good telescope, you can see it. Now this is what I call, astronomers nerding out. So this is the Ring Nebula. You see a little fuzzy patch there. It's a very faint galaxy. I blew this picture up. You see the little fuzzy patch? And this is a professional observatory would have taken this one. And that's the galaxy there. It's called the North American Nebula. It's up in Cygnus. It's so big. This is taken with almost like a 300 millimeter telephoto lens. If you're in a dark sky, like up at Tobermory, Algonquin Park or further, you might make it out, or you might make it out with a pair of binoculars. It's called the Rosette Nebula in Monoceros. It's a winter thing. You can see some of the nebulosity, and you can see there's a cluster of stars in here when you're looking through a telescope. This is called the California Nebula in Perseus. Very, very large, so you need a low power, large aperture telescope. But seen a little bit of it a few times, but not very well. And this is the Cocoon Nebula in Cygnus. And what's neat about this one is it's actually moving through the sky. And as it's moving, it's leaving dust behind. So the dark parts you see in there are actually blocking the stars in the background. And this is the Lagoon Nebula in Sagittarius. Absolutely fantastic to look at with a telescope. It would probably be one of the things we'd be looking at if we were in person. The moon sometimes washes out a little bit. It still would be a fantastic object to look at through even a 130 like telescope like mine. Then we get into the galaxies. So you can see, got some descriptions here.
So Diane wants to know, are all of those colors that we're seeing, are those gases?
Yeah, they're gases, and some are reflection nebula, and some are what's called emission nebula. So some are just the light of its gas and light from a star is bouncing off of it. And sometimes the light that you see is actually the gas is excited, so it's energized. So this one...
Lou wants to know, is there an app for the iPad that would show the sky and the names of the different things that you're seeing?
Yes. Sky Safari, I think, is one. And then you probably, I'm not an iPad user, so, or something like that. I think on the iPhone, there's apps where you can get, and you hold your phone up to the sky, and it orients it. It knows where it is, and it knows where it's pointing, and it tells you what you should be seeing. So this galaxy is M31, the Great Andromeda Galaxy. It's probably the best one that you can see without a telescope on a dark night. If you know where to look, it's in the constellation Andromeda, and just a little bit south of Cassiopeia. And you look up and you see a fuzzy little patch in the sky. You put a pair of binoculars and you'll see a bigger fuzzy patch kind of elongated like that. And I just love taking pictures of it. You see all the dust lanes and everything. And if you get a really good a lot of people want to look at this with a telescope, but it's so big that you can only look at a little portion of it, like maybe a quarter of each of those sections at a time. But you can go back and forth and you can see the dust lanes. Best view I had was with a 6-inch telescope one night. Somebody handmade a refractor. And it was a nice night. They had a really expensive eyepiece on it. And he was going for coffee, and they said, "Here, go ahead." So just soaked in the starlight. And just to give you an idea how big it is, there's the moon at the same scale. So it's really big in the sky. There's one that on a really, really good night, you might be able to see this without a telescope. It's just below Andromeda, the Triangulum Galaxy. Or just for point of reference, I just want to mention that if you're going to be around for a few billion years, the Andromeda Galaxy is coming towards us. So in about 2 or 3 billion years, I'm not exactly sure how many it is, the entire sky will be filled up with nothing but Andromeda. You won't see anything else. It'll just be the Andromeda Galaxy. And then our Milky Way and the Andromeda will merge, and all kinds of weird things happen, but stars rarely ever collide. They just kind of interact gravitationally, and all this happens in slow motion. This is a neat little galaxy. It's a little difficult to see. It's low in the our southern sky, called the Silver Dollar Galaxy. This is M101. This is up in the northern sky, and just off of Ursa Major. This is also a really good one. If you have about an 8-inch or bigger telescope, this is a fantastic sight. And that's kind of the end of that presentation. I just talk about little things. And if you want a few resources, Stellarium is a good one. That's the program I was showing you. Night Watch is a really good book by Terence Dickinson. If you want to find out about what's going on, spaceweather.com gives you predictions of comets, satellites, International Space Station, all kinds of things like that. And actually, the Heavens Above does that. Space Weather gives you the sun. Yeah, gives you the sun and the meteors and things like that. So these two sites are really good. And if you want to see neat photographs, apod.com, Astrophoto of the Day. Every day they select a picture from somebody. It could be an historical picture. It could be something that's happening in the sky right now. Really good photographs. Okay, what's our time here? Well,
yeah, we're almost done. So does anyone else have any other questions that we have? We talked about a lot of really, really cool things tonight. So does anybody else have any other questions before we wrap everything up? Do you have a good recommendation for a telescope for a beginner who's just getting into this, and how much would that cost?
Good. Good telescope for beginners. It kind of depends on what you want to do. So you have to kind of identify what objects you want to look at. Some people want to look at like the nebulas and things like that. So you want to get a fairly big one, something called a Dobsonian, like an 8-inch. But if you want to look at the planets, the moon, you can probably start at around $300 for one that's manually operated. And they have telescopes now that are really neat. Celestron makes them. I think Meade might make them as well. And they're started around $1,000 to $1,500. You can get in a 6 or an 8-inch size. And what you do is you set the telescope up. It has a little camera on top. You take the lens cap off on the telescope. You take the lens cap off on the camera. You roughly point it to the northern sky, and you say start. And it goes around and it takes pictures for about 5 minutes. So it knows what it's pointing at. So it knows, it orients itself. And when it's done that process, then you tell it what you want to look at. You want to look at Saturn? It'll just swing over and uses the camera to find Saturn and puts it right in your eyepiece. So it's probably the easiest one that's like versatile. But that you're spending a bit of money. But if you want to go find a good telescope store, and if it's a reputable store, they will ask you what it is that you want to look at and how much you want to spend, and they'll put a good fit together. What I tell people is, if you're interested in looking, get a good pair of binoculars now. A lot of people who watch these webinars and things are already into birding and things like that, or nature. So you might already have a good pair of binoculars. If you don't, that's the best way to start, is just get a pair of binoculars. And if you can get a little bracket that you can mount it on a tripod, putting a pair of binoculars on tripod for astronomy, it increases what you can see by a factor of almost 10. Just not having a jiggle and everything is just absolutely amazing. Now, if anybody, I'll plug, a friend of mine has a store. So if you're interested, called KW Telescope in Kitchener. And he is extremely reasonable, and he won't sell you something that you can't use. He's seen too many people think that the more money you spend, the better telescope you get. Well, it's not really true, because you got a telescope that's too heavy, too big, too complicated, it'll just gather dust. So that's my long and short answer. So,
are there any other stores in other parts of Southern Ontario, people who live a little bit further away from KW?
Yeah, there's a website called Canada Astro Buy and Sell, and there's a whole bunch of the stores around that have, and there's a couple of online stores only. There's Canada Telescopes, and there's Ontario Telescopes, and they're both very reputable dealers of astronomy equipment. But they don't have a brick and mortar, so you can't quite interact with them in the same way. And there are a couple others whose reputation is not that good. I won't mention their names though. So.
Okay, good to know. Jean wants to know how to find out about, I'm thinking she's meaning astronomy nights that are open to the public.
Star parties, I'm guessing you're talking about.
Yeah, star parties, I think.
Yeah. Yeah, well, our club, our North Shore Area's Amateur Astronomers does that. So, and there are, well, basically public star parties are always open to the public. So, and we advertise it. We try to have them two times a year. So our May one got totally blown out, and we're going to try, similar to this Zoom, I think we're going to try to YouTube one in September, do a similar thing like this. Have a virtual star party. But once we're out back in the field again, where people can gather, we'll have real parties. Our local one we hold in the Wyndham Center, it's called the Windell Park. And if you go on the North Shore Erie Amateur Astronomer website, you can see, and they're also co-hosted by Norfolk, so they're always in the Norfolk activity guide. They always mention the date and the location for that. And if you're not from this area, you kind of just Google whatever local astronomy club is around and what they're doing.
Julia wants to know, when is the best time at night to look at the sky?
I would say from the moment it gets dark. I know it's a bit of a glib answer, but it kind of depends on what you want to look at. So sometimes if I want to photograph an object, it might not rise until midnight, or get high enough in the sky until midnight. So like right now, the Moon, Jupiter, and Saturn are in great position to be out there viewing them right from about 8:30 on and until they set. And that's probably around midnight or a little bit later. And in the winter time, I mean, you've got probably 12 hours to get out there, like from 6 o'clock till 6 o'clock. Believe it or not, there's something called astronomical twilight. Like you get different times for twilight. So astronomical twilight in June is from about 11 o'clock. It doesn't get totally dark until after 11 in the evening. And it starts getting light again at about 3:30 in the morning. So you only got about a 4-hour window of really dark skies.
And so then if you're, Julia wanted to look at the constellations, so that it doesn't really matter too much then, or does that get influenced at all?
Yeah, well, I'm gonna move to a different screen here. So did I close it? I must have closed it. Okay, well, if you get into the Stellarium program, that's not what we're in here, but you get into the Stellarium program, you can click on constellations and it'll show you the constellation lines and the constellation names. So if there's any particular constellations you want to look at, it'll show you when, and you can go through the timeline like I was doing, and you can see what constellations they are. Now, one little thing I wanted to mention, at our star parties in the past, like our physical star parties, we usually had 1 or 2 members have, I'm not sure if anybody's seen the green laser pointers that shine beautifully in the sky, and you can point out the constellations with them. Well, Transport Canada has made those illegal to use for anybody but who isn't trained in using them. So if you're caught using one without proper authorization, and they can find you, and they have ways of finding people who do that, you can get fined or even jailed for using one of those.
Wow, that is good to know.
And the only qualified, right now, the only people qualified would be members of the RESC, and they have to have taken a test to identify how to do it. And the protocol is you can only use it at star parties, and one person uses it and the other one has to kind of watch the sky. And as soon as you see a plane or anything, they have to stop using it, because pilots have been flashed and have almost lost control of their airplanes because people decide to shine their green laser lights. They don't realize that green laser lights can go dozens of miles up in the sky.
Wow, that's pretty wild. Well, okay, I think that's it for the questions for tonight. So we wanted to thank you so, so much for coming and for doing this and for spending your evening with us. Everybody who participated, we had such a great, so many questions, awesome questions in the chat, and Bernd, of course, for helping and sharing all of your incredible knowledge with us. Thank you so, so much.
Okay, well, you're welcome. This was fun. So I'm glad that it cleared up. I wouldn't have predicted this this afternoon when the storm was on.
I know, that was a pretty epic storm. Yeah, definitely.
I've never seen it get so dark in the afternoon as it did this afternoon. So
yes, it was very, very dark out. Yes, but all right. So for everybody who's joined us, you'll be receiving an email within the next week or so that will have, hopefully sooner than that, but that will have a copy of the video, of this video that will be linked on our YouTube page, and we'll have some of the other notes and things that we've taken for tonight as well. Thanks so much for joining us again, and I hope you all have a lovely evening.